In this video, we will practice calculating the change in arithmetic and geometric sequences. This is AP Precalculus Topic 2.1. If you appreciate this content, please help me out by hitting the like button. For each of the following, determine if the given sequence is arithmetic, geometric, or neither. Arithmetic sequences show a common difference between successive terms. In this example, the common difference d equals 2. For geometric sequences, successive terms have a common ratio. In this case, the common ratio r equals 2. Let's check number 1 for a common ratio to see if it's arithmetic. From 12 to 7, that's minus 5. And then from 7 to 2, that's another minus 5. From 2 to negative 3 is another minus 5. And from 3 to negative 8 is another minus 5. This is arithmetic with a common ratio r equals negative 5. For number 2, the common ratio is jumping out at me. 5 times 2 is 10. 10 times 2 is 20. And 20 times 2 is 40. This is geometric with a common ratio r equals 2. We can quickly see that number 3 is not arithmetic because from 20 to 10, that's minus 10. But then from 10 to 5, that's negative 5. So no common difference. How about a common ratio? Half of 20 is 10. So we are multiplying by 1/2. Half of 10 is 5. So times 1/2 again. And of course, half of 5 is 5/2. So, geometric, common ratio, 1/2. For number 4, I feel a common ratio coming on. But first, understand that the number 1 is the same as 3/3. And the number 3 is the same as 9/3. I just want them all to have a common denominator so we can see the differences more easily. From 1/3 to 3/3, that's plus 2/3. And then 3/3 plus another 2/3 is 5/3. 5/3 plus 2/3 is 7/3. And 7/3 plus 2/3 is 9/3. Arithmetic, common difference, d equals 2/3. Number 5, let's check for a common difference. Well, from 1 to 1, that's plus nothing. And from 1 to 2, that's plus 1. So no common difference. How about a common ratio? 1 divided by 1. I'm doing each term divided by the previous term. 1 divided by 1 is 1. 2 divided by 1 is 2. So no common ratio either. Number 5 is neither arithmetic nor geometric. For number 6, let's generate the first 4 terms by plugging in 0, 1, 2, and 3 for n. If we plug in 0, that gives us 3/2 for the first term. If we plug in 1, 3 plus 1 is 4, divided by 2 is 2. If we plug in 2, that's 5/2. In fact, I'm noticing the denominators of 2. I think I will write them all with denominator 2. So that 2 is the same as 4/2. And then if I plug in 3, that's going to be 6/2. From 3/2 to 4/2, that's plus 1/2. From 4/2 to 5/2, plus 1/2 again. From 5/2 to 6/2, that is plus 1/2 again. Number 6 is arithmetic with a common difference of 1/2. Let an be an arithmetic sequence with the following properties. For each of the following, find an expression an and then find a11. An arithmetic sequence can be modeled using the formula an is equal to ak plus d times n minus k, where an is the nth term and ak is term k. D, of course, is the common difference. For number 7, we are given two terms of an arithmetic sequence. We can substitute one for an and one for ak. Let's put the one with the larger subscript first. So a8 and then a3. Notice this n minus k is 8 minus 3. So a8 is 17, so we have 17 equals a3 is 7 plus 8 minus 3 is 5. I'm going to go ahead and put that in the front. Subtracting 7 from both sides, we get 10 is equal to 5d. And dividing both sides by 5, we get d is equal to 2. Now we can use this common difference to write our expression for an. We can use either one of these for ak. I'm just going to use the smaller one, the 7, plus, now our common difference is 2, times n minus k is the subscript 3. So this is our expression for an. Let's use this expression to find a11. a11 will equal 7 plus 2 times 11 minus 3. So a11 will equal 7 plus 11 minus 3 is 8 times 2 is 16. So a11 will equal 23. Number 8. Let's put the a6 in the front. So we have a6 is equal to a2 plus d times 6 minus 2. So that's negative 9 is equal to negative 3 plus 6 minus 2 is 4. So I will put 4d. Adding 3 to both sides, we get negative 6 is equal to 4d. And dividing both sides by 4, that will be negative 6 over 4, which reduces to negative 3 over 2. Now let's write the expression for an using this common difference. An will equal, and I'm going to use the a2, so negative 3 plus, the common difference is negative 3 over 2, so actually minus 3 over 2. N minus, it's got to be n minus k. The negative 3 came from here, so the k is this 2. So n minus 2. So that's it. This is the expression for an. Next, we are meant to find a11. So this will be negative 3 minus 3 over 2 times 11 minus 2. So a11 is going to equal negative 3 minus 3 over 2 times 9. I'm going to go ahead and write this with a denominator of 2. So a11 will equal negative 6 over 2 minus 27 over 2. So a11 will equal negative 33 over 2. For number 9, we are given one term and the common difference. So this will be a little bit easier. An equals, we can let the one term be ak. I'm going to go ahead and put the 7, but remember the subscript is 5. So that's the k right there. So plus d, which is negative 4, so I'm just going to put minus 4. And then n minus k. That's n minus 5. And that's it. This is the expression for an. Now let's find a11. a11 will be 7 minus 4 times 11 minus 5. So a11 will equal 7 minus 4 times 6. So a11 will equal 7 minus 24. So a11 is negative 17. Number 10 is another where they have given us the common difference. So these are pretty easy. an equals ak. This will be our ak. So I'm going to write negative 1, but remember the k is 4. Plus the common difference, which is 2/3. And then we have the n minus k, which will be n minus 4. And that's it. This is the expression for an, and we can use it to find a11, which will be negative 1 plus 2/3 times 11 minus 4. So a11 will equal negative 1 plus 2/3 times 7. 2/3 times 7 is 2/3 times 7 over 1. So you multiply straight across and get 14 over 3. Let's replace the negative 1 with negative 3/3 so we have like denominators. So a11 will equal 11 over 3. In number 11, they have given us the arithmetic sequence graphically. Looking at the first two terms, we see that a0 is 10 and a1 is 7. From 10 to 7, the value decreases by 3, so the common difference is negative 3. And we can now begin writing the expression for an. For ak, I'm going to use a1. So I'm going to put the 7, but remember the k is 1. Plus the common difference of negative 3, so actually I will just put minus 3. And then comes the n minus k, and again that k is 1, so n minus 1. And just like that, we have an expression for an. Let's use our expression for an to find a11, which will be 7 minus 3 times 11 minus 1. Therefore, a11 will be 7 minus 3 times 10. So a11 will be 7 minus 30. So a11 will equal negative 23. Easy peasy. Here's another way you can find an expression for an when you are given the arithmetic sequence graphically like this. So an arithmetic sequence is very much like a linear equation, except for it's not continuous. But still we can make an analogy. So a linear equation takes the form y equals mx plus b. Now compare that to a modified version of a formula for an, which goes an equals dn plus a0. So the slope is d, and the y-intercept is a0, the first term. So in this case we get an is equal to the common difference of negative 3, so negative 3n, and then plus 10, which is, well, still the y-intercept. This formula is equivalent to the one we got. And you can tell because if we go ahead and try to find a11 now, a11, that would be negative 3 times 11 plus 10. So a11 would be negative 33 plus 10. So a11 would be negative 23, just like we got before. Notice for this shortcut to work, we have to be given a 0. We need the y-intercept. So this method will not work on number 12 because we are not given a 0. We are not given the y-intercept. Because we are not given two terms in a row, we cannot immediately calculate the common difference. But we see that a2 is 4 and a5 is -3. We can use these two terms to find the common difference. Let's plug these two terms into the formula. I like to put the one with the larger subscript first. So we have a5 equals a2 plus d times n minus k. That's going to be the 5 minus 2. In fact, well, I'll go ahead and write it. 5 minus 2. So a5 is -3. So we have -3 equals a2 is 4. We don't know the common difference yet. However, 5 minus 2 is 3. I'm going to go ahead and put that in the front. Subtracting 4 from both sides gives us -7 is equal to 3d. Dividing both sides by 3, we find that d is -7/3. So we can now write an expression for an, which will be, I'm going to use a2, so I'll put 4, but remember that k is 2. The common difference comes next, so -7/3, and then n minus k, therefore n minus 2. This is an expression for an. Let's use it to find a11. a11 will equal 4 minus 7/3 times 11 minus 2. So a11 will equal 4 minus 7/3 times 9. 3 goes into 9 3 times. So I'm kind of doing like this. So a11 is 4 minus 21. So a11 is -17. Let Gn be a geometric sequence with the following properties. For each of the following, find an expression for Gn, and then find G6. Geometric sequences can be modeled using the formula Gn equals Gk times the common ratio r to the n minus k power. In this formula, Gn is the nth term, and Gk is term k. For number 13, we are given the common ratio r, and one term, which we will use for Gk. So we can begin to write the expression for Gn, which will equal G1. I'm going to go ahead and just put the 5, but remember, the k is 1, times the common ratio of -2 to the n minus k power, so that will be n minus 1. That's our expression for Gn. Let's use it to find G6, the sixth term. G6 will equal 5 times -2 to the 6 minus 1 power. So G6 will equal 5 times -2 to the 5th power. 2 to the 5th power is 32. So -2 to the 5th power will be -32. So G6 is -160. Jumping right in for number 14, Gn will equal Gk, which we will use G2, therefore 8. Just remember that k is 2, times the common ratio, which is 1/2, to the n minus k power. There's your 2. This is one expression for Gn. Let's use it to find G6. So that will be 8 times 1/2 to the 6 minus 2 power. I'm going to go ahead and put 4. 1 to the 4th power is 1. 2 to the 4th power is 16. So we get G6 is equal to 8 times 1 over 16. If you multiply straight across, this is 8 over 16. So this simplifies to 1/2. That's it for number 14. For number 15, we are not given the common ratio. So let's plug in G2 and G5 so we can find that common ratio R. I'm going to put G5 in the front. I always start with the larger subscript. So G5 will equal G2 times the common ratio and then n minus k power. So that's going to be 5 minus 2, which is the third power. Substituting the 27 and the 1, we get 27 is equal to 1, which I don't need to write, times r to the third power. Taking the cube root of both sides, we get r is equal to 3. Now we can write Gn. Gn equals, I'm going to use the G2 as Gk this time. So I'm just going to put a 1, but I'm not going to write the 1. And then we have the r, which is 3, to the n minus k power. So that's n minus 2. So this is one of many expressions for Gn. Let's use it to find G6. G6 will be 3 to the 6 minus 2 power. Therefore, G6 will be 3 to the 4th power. So G6 is equal to 81. Again, we are not given the common ratio. Let's plug in G7 in the front and G4 for Gk so we can find R. So we have G7 is equal to G4 times R to the 7 minus 4 power. So that'll be the third power. But G7 is 32 over 9. So we have 32 over 9 is equal to G4, which is negative 12, times R to the third power. I guess I can stop writing the parentheses right now, R to the third power. I can divide both sides of the equation by negative 12 by putting negative 12 in the denominator over here. I'm showing it this way because I would rather reduce the 32 and the 12 while the numbers are small, rather than multiplying 12 times 9 and getting a big old number, then I still have to reduce. So I notice that 32 and 12 are both divisible by 4. So if I divide both of these by 4, I get 8 and 3. That leaves us with negative 8 over 27, 3 times 9. Both of these numbers are perfect cubes. So taking the cube root of both sides, and an odd root leaves a negative as a negative. So I'm going to have r equals negative, and the cube root of 8 is 2, while the cube root of 27 is 3. Now that we have r, we can write an expression for Gn. So Gn will equal, I'm going to use G4 as my Gk, so I'm going to go ahead and put negative 12 right here. Just remember that the k is 4. And then we have the r, which is negative 2/3, and then n minus k, n minus 4. This is one of many expressions for Gn. Let's use it to find G6. So negative 12, negative 2/3 to the 6 minus 4 power, so that's squared. So G6 will equal negative 12 times, 2 squared is 4, and 3 squared is 9. So I'm going to have 4 over 9, because when you square a negative number, it becomes positive. This is like 12 over 1. I prefer to reduce these as they are. both 12 and 9 are divisible by 3. So this is going to become a -4, and this is going to become a 3. So G6 will equal -16 over 3. For number 17, we are given this graphical representation of the geometric sequence. We are not given consecutive values, so we will have to find the common ratio as we did before. I'm going to put G4 in for Gn. So we have G4 equals, and then I will let Gk be G1. So G1 times R to the n minus k power, that's 4 minus 1, which is the third power. But G4, of course, is the 3, so we have 3 equals. And then G1 is 1, which I am not going to write. So I'm left with 3 is equal to R to the third power. Taking the cube root of both sides, we find that R is the cube root of 3. Interesting. So now that we have R, we can begin to write Gn. So Gn will equal, and I'm just going to stick with G1 right now, so which is 1, and remember that k is 1. So I will have the cube root of 3 to the n minus k power, so to the n minus 1 power. So this is an expression for Gn. Let's use it to find G6. So G6 will equal the cube root of 3 to the 6 minus 1 power. So that's to the 5th power. There's not a ton more we can do with this. So this is one expression for G6. So for what it's worth, the cube root of a number is the same thing as raising that number to the 1/3 power. So the cube root of 3 is the same thing as 3 to the 1/3 power. So G6 equals 3 to the 1/3 power to the 5th power. So I can write another form for G6 because when you raise a power to a power, you multiply. And 1/3 times 5 over 1 is 5/3. So this is 3 to the 5/3 power. So this is another way of writing G6. While I'm showing answers in different forms, let me show you a different form for Gn as well. Again, using the fact that the cube root of 3 is the same thing as 3 to the 1/3 power. So Gn becomes 3 to the 1/3 power to the n minus 1 power. And again, when you have a power raised to a power, you multiply. So this would be the same thing as Gn is equal to 3 to the 1/3 times n minus 1 power. So right there, this is already another form. And one more slightly different form. 1/3 times n minus 1 would be the same thing as n minus 1 over 3. Why am I showing you all of these different forms if we already had the answer in the first place? That's because a lot of your AP exam will be multiple choice questions. So if they ask you to find Gn, it may not look like this. It might look like one of these. So I need you to have this skill of transformation so you can pick out the correct answer from a multiple choice list of options. Let's do one more of these geometric sequences in graphical form. We can see that A1 is 6 and A2 is -3. These are consecutive terms. So we should be able to find the common ratio by simply dividing the second term by the first term. So that's going to be negative 3 divided by 6, which is negative 1/2. So that's the short way to find r. If you did not notice that, you would have to go through the motions like we've been doing, which I'm going to run through that real quick, just in case you didn't notice. The long way would be a2 is equal to a1 times r to the 2 minus 1 power, which is 1. So that's negative 3 is equal to 6r, and then you would divide both sides by 6, and you would get r equals negative 1/2. Now we can write Gn. I'm going to use a1 for my gk, so I will put 6 right here, and the r we just found to be negative 1/2, and then it's n minus k. My k value is 1, so n minus 1. This is one expression for Gn. Let's use it to find G6. So it would be 6 times negative 1/2 to the 6 minus 1 power. So that's the 5th power. 1 to the 5th power is 1. 2 to the 5th power is 32. So G6 will equal 6 times negative 1 over 32. So this is, I'm just going to show the steps. So G6 is equal to negative 6 over 32. Dividing both of these by 2, G6 is equal to negative 3 over 16. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.